All right, today we're going to be looking at lesson 8.5, and we're going to be using the distributive property to solve equations. Now, when we talk about the distributive property, if I look down here on number 3, we're actually talking about when we pull out that GCF. That's what that's talking about. And we'll be solving equations that have GCFs but are going to be set equal to 0. And if they're not set equal to 0, we're going to set them equal to 0. So the first word we have to define here is called zero product property, which you should have be a little familiar with from yesterday's project on Noel Ryan. Okay. And so we are going to zoom in, and zero product property is just simply when you set factors equal to 0. Okay. All right, so on my first example here, I see that they have actually already factored it for me. So when it's already in factored form and they have already pulled out this 3n, so they've already pulled out the GCF and they're writing that out here. So this guy right here is your GCF. Okay, you're just simply going to set each factor equal to 0. So I'm going to take the 3n and set it equal to 0 and the n plus 2 and set it equal to 0. So I've got 3n equals 0, n plus 2 equals 0. Okay, so on this one I'm going to divide by 3. N will equal 0. And on this I subtract 2. And n will equal negative 2. And so on this solution I have two answers that will work for this particular equation up here. Okay? Alright, so then let's go ahead and take a look then at number 2. And number 2, again, you can see you got those parentheses, so it's already been factored for you. So all we're going to do is take the 2d plus 6 and set it equal to 0, and the 3d minus 15 and set that equal to 0. Alright, so I'm going to start by subtracting the 6 on the first one here, getting negative 6 equal to 2d. Divide by 2 and get negative 3. On this one I'm going to add that 15 to the other side, then I'm going to divide by 3 and get d equals 5. And so my solution here will be negative 3 and 5. So realize we talked yesterday with Noel and Ryan, and you did your graphs, and that this is saying it's going to cross at negative 3 and it's going to be crossing at 5. Okay? And so we are actually going to start getting two solutions that cross the x-axis. Okay? Alright, so example number 3 here. Now in this particular case, this has actually not been factored yet. So if it hasn't been factored, you are going to have to do your factoring first. So the first thing I'm going to do is always pull out my GCF. So I'm going to take out an 8b and have b minus 5 left. Now this looks really similar to what we just did in number 1. We've got both our factors, just set them equal to 0. So 8b equals 0 and b minus 5 equals 0. Again, divide by the 8. And b equals 0 here, add the 5, and b equals 5. So it's going to cross that x-axis at 0 and 5. Alright, and on the next example here, if we look at this, we'll notice that it's not actually set equal to 0. Zero product property states that it has to be equal to 0. So the first thing I'm going to do is subtract off the 10x and put it on the other side. Okay, so off the side here, must be set equal to 0 then factor and solve. Okay, but that part right there, it has to be set equal to 0. This is the big dog. You've got to do that first, always. So we're going to, oh, I forgot, I should put addition there. So we're going to add the 10 to the other side. So now if I'm going to look at this, I'm going to pull out an x and have x plus 10 left over inside equals 0. Again, I'm going to take the x on the outside, set it equal to 0. So this guy, and then I'm going to take the x plus 10 and set it equal to 0. So I have x equals 0 and x equals negative 10. So I've got 0 and negative 10. Alright, and our last problem here is a word problem, and you're going to notice that in this particular unit we're going to start picking up a lot more word problems. It says the hop of a kangaroo can be modeled by h equals 24t minus 16t squared, where h represents the height of the hop in meters and t is the time in seconds. find the values of t when h equals 0, okay? So when I'm looking at this problem, they've already told me that h equals 0, and they've given me the equation to work with here. So I'm just going to simply set it up. 0 equals, and then I've got my 24t minus 16t squared. So all I did was plug in 0 there for your h, okay? And now I'm actually sitting at the zero product property rule. So I've got it set equal to 0. Now I'm going to pull out a GCF. I'm going to pull out an 8t, and I will have 3 minus 2t left. All right, so again, set each factor equal to 0. So 0 equals 8t, and 0 equals 3 minus 2t. Divide by 8, so 0 equals t. And on this one, I'm going to subtract the 3 off, so negative 3 equals negative 2t. And then I'm going to divide by negative 2. So I end up with 3 halves equals t, or if you want to think about it as 1.5 equals t, either one of those is fine. So my answer is going to be, at 0 seconds, realize we're talking about seconds here, we're on the ground, and then at either 3 halves or 1.5 seconds, he then returns back to the ground. Okay, so if you're thinking about this, he's starting here at 0, he's going 1, 2, he's going to hop up and then return back to the ground at 1.5. So he's actually at the ground twice, is starting and then where he finishes. All right, and that concludes the notes for 8.5 zero product property.